everyone, welcome back to Manufacturing Hub on this Wednesday afternoon. If you guys are watching and joining us live, if you're not watching and joining us live, it's probably not a Wednesday afternoon. It would be a really awesome coincidence if it was, though. So super excited to go bring Caleb back. We'll go reintroduce Caleb in just a moment. As we talk about the data layers and the foundations of manufacturing intelligence all this month long on Manufacturing Hub, it felt like it was a prime example and opportunity to go have a conversation that Caleb and I have been kind of dancing around of MTP and MCP and safe AI in manufacturing. So I'm excited to go have this conversation as we continue down that. Having said that, if you guys are new here, welcome. If you've been here before, welcome back. If you guys are new here, every Wednesday afternoon, we have a 60 to 75-minute conversation where we talk about all fun things in manufacturing and automation. As I said, this month, we're talking all about the data foundation layers and of manufacturing intelligence. And so very happy to have you guys here. If you have any questions for Caleb, I imagine most of the questions for the show are going to be to Caleb when we go talk about these things, or I suppose Vlad or myself. Please feel free to go ahead and ask. We are happy to go ahead and jump in. We try to have this be as interactive of a show as possible. Having said that, and before we go kick off, I actually do have like one really awesome thing. I don't know if Vlad or Caleb have seen, but Tim Wilborn or the Wilborns have officially got their silver play button on YouTube for 100,000 subscribers, which was really awesome. I saw that they did a live stream, and I was really tempted to use Amber's intro because she was very excited about it to go pump up the energy in this show. But I feel like that probably is something that we should have asked her for permission for before we go through and do that. Having said that, and without further ado, everyone officially welcome to Manufacturing Hub. This is episode 220. My name is Dave. This guy up here is Vlad, and we'd like to officially welcome Caleb back to the show. Caleb, thank you so much for being here. Welcome.
It's great to have you, and I'd like to note that the Wilburns certainly deserve that reward.
Absolutely.
It was a long time in the making. I think very few people truly realize the effort it takes to get there, especially in our space. You know what I mean? I think there's very, very few people that have reached that milestone. So it is absolutely awesome. Caleb, before we dive into all of the acronyms that are part of the title for this episode, could you give us a reintroduction, please? I know you've been on a couple of episodes, but could you give us an overview of how you got started in manufacturing, an overview of your career, and ultimately you have a great role at Siemens as well. So just want to get a little bit more information as the NDAs permit.
Yeah, so the nice thing is I am not the most consistent person in the way that I introduce myself. In fact, earlier today, I introduced myself as not having existed in this dimension prior to 2019, and about half the audience didn't even catch it. So I actually got my start in this business long before I got my start. That is to say that I started actually in high school. I got my Cisco networking certification, for those of you familiar with the CCNA. And then I bounced around doing non-technical and non-manufacturing jobs. The closest would have been pharma. I was a security guard in pharma. And then I would say about 15 years ago, maybe I got a position as an automation technician from having had my Cisco certification. Because they wanted someone who had some background, some knowledge of networking. And this was in oil and gas. This is an upstream oil and gas E&P company. And so since then, I've really, really enjoyed the space and kind of absorbed as much information as I could, from SCADA to MES to all sorts of other topics in the area, PLCs and DCS systems, all sorts of other topics in the area. Then started my own systems integrator, electrical contractor, did that for a few years. Then went to work for a Silicon Valley company doing product development in the space. Then started another company. That one was an embedded software engineering company. And now here I am at Siemens. So it seems like I kind of cycle back and forth between owning my own companies, doing something in the space, which I found happens to be the best way to get growth, because you get placed into situations that a single employer may not put you in, if you own your own company, and then getting sort of more generalized experience in the companies I've worked for. So Siemens is by far the largest company I've ever worked for, but I've been working in this space for a while. Usually as a systems integrator, dealing directly with end users.
Super interesting. I guess there's many questions that I can ask you as a follow-up, but you probably have mentioned this in the past, but the start through the CCNA is, I would say, is a bit unusual, right? I think that a lot of people that pursue those certifications, and actually, like I took the CCNA certification myself, they usually end up on the IT side. So I'm curious, maybe what that kind of initial step was, and would you recommend? Because I talk to many, as you probably do as well, plant engineers that are specialized, in PLCs and HMIs and know very, I would say, little on the networking side. Do you think it's still a good, solid certification to take
I
nowadays?
would say it depends. So it was highly valued by the oil and gas company. If you have any experience in upstream oil and gas, you know that it's extremely communications heavy because of the wide, highly distributed nature. So it's like taking a manufacturing facility and spreading it out across the lower third of the United States. So what ends up happening is you have to actually transcend beyond your traditional layer 2 protocols, and you start getting into dynamic routing, OSPF, layer 3 type stuff. And when you do in that world, there's a lot more, I would call it what people traditionally consider IT type networking in spaces where just to get data back for a SCADA requires 60 mile point-to-point radio shots with layer 3 routers at every tower. So it's kind of I would say, certainly if you are in industries like that, it's very valuable. Since then I've done a lot more in what I would consider to be OT networking. Where you've got the latency and the rings, and VLANs are more common than layer 3. And in that case, I think the trainings provided by the different manufacturers like Rockwell or Siemens, although Rockwell at the end of the day mostly Cisco as well, or Hirschman or Mox or any of the other ones, is just as good, particularly if you find yourself more in what they would consider to be traditional manufacturing.
Yeah, and it's an interesting. I don't want to spend a whole lot of time on the networking side, but it's an interesting subject, especially now that we're extracting more and more data. We're migrating away from legacy protocols. I think it's no longer an option to just be able to deploy Data Highway Plus or whatever proprietary network that existed in the past. Everything's going on a network, so you need to be able to set it up properly. And as you said, a lot of I don't want to say a lot of, but some of the vendors are just using a white label approach where they put their own layer on top of a switch. And I actually had a comment from a director over the weekend who basically told me that you need to be able to operate everything via CLI, as you know, like via the Cisco iOS. And so there's definitely value in being able to manage that infrastructure, which is now bleeding more and more into OT, right? That these are not rack mounted switches. These are, the cube switches that you see inside of the panels. And so it's, I think it's going to be challenging for many OT engineers.
I would say you just made an interesting point about CLI that I think actually expands beyond just networking. So for example, if you're really doing a cloud infrastructure, for example, it's not actually best practice to use the user interface to configure cloud resources. It's actually better to use something like Terraform, which is generally speaking to operate as CLI based. I would contend that CLI is a new core skill needed just in general, being able to operate versus. So I would say just in general, that's something people should get comfortable doing.
Yeah, I would say this is another very brief, short comment. I'm not going to mention the manufacturer's name, but basically, when I called their support, they basically told me the web interface is not so great in different words, and you should be using CLI as well. So, I had to connect in via PuTTY and be able to issue commands as you've studied during
So
the CCNA
any of
as
the
well. So,
OEMs where they have a good chunk of their development of their workforce are software developers. So that's one thing that people don't realize is that the OEMs who have a lot of software developers on staff, they themselves internally will certainly be CLI heavy. So one of the things that they'll usually the last thing to get made will be the user interface for the end users. And so so if you want to think like the manufacturer thinks, then usually CLI is a safer way to go about it. That's why I'm not surprised
Yep.
you got that, because that's like even the user interfaces are generally run off of the CLI or an API between a server and a client. So it's all CLI in the end.
Well, yeah, I mean, it begs the question as to why you put a wrapper around that hardware in the first place. But look, that's a whole other, I think, conversation and debate. Let me move us on to an introduction of, I guess, the first question before I pass it on to Dave. But one of the acronyms we've got is MCP, right, or Machine Context Protocol. And so, could you give us an overview and, I guess, a definition of what that is for someone who's completely unaware of what it is?
So I'll take a one step back so I can take a running step towards this. So if anyone's familiar with the digital maturity model, particularly for manufacturing, there's a level of there's a level that you would aspire to get to, what they call level 5, which is adaptive plant. An adaptive plant is sort of these self-organizing, autonomous, modular, distributed kind of architecture that all of the concepts that we'll talk about today kind of are either leading up to or fit within. So specifically, you mentioned Model Context Protocol, or MCP, is generally speaking, it's an open protocol. It was introduced by Anthropic that allows LLMs in particular, but AI agents interact with tools and simulation APIs in a structured, context-aware way. The topic that I spend most of my time thinking is sort of tangential is what we call a module type package, which is it was developed as a methodology originally for being able to have a vendor agnostic way that describes services, data, interfaces of modular process equipment using AutomationML, usually sitting on top of OPC UA, but it's kind of separate from. It's not something you should think about. It's not like PackML. It's more than an information model. That is what I spend most of my time thinking about, and I have really specific reasons why, and not for the reasons that they state in the standard. So one of the things I'll say just right off the bat is that if you're talking to me about module type package, it will sound slightly different than if you're talking to most other people about it, because I actually consider it to have a broader application area than what the original developers of the standard made it both.
So let's take a step back, right, and maybe then define MTP a little bit better, right? I guess I'm comfortable with going on either direction, but I guess if we want to start with MTP first, could you give us a bit of an overview of what it allows, and I guess what does it solve from a practical standpoint for a manufacturer? So
I will, before we go too far into it, I'll probably start pulling up diagrams, just because it's kind of like, talking about unified namespace or OPC UA or anything. It's really hard to describe, using just words, but I'm going to take a stab at it. it's been described as USB, as the USB of manufacturing. I know IO-Link has also been described that way, so I'm gonna, but basically what it is that what it's supposed to enable is, if you had a machine builder and they made their process skid, let's just say it's a fill and finish line or just some modular piece of equipment. So first of all, it assumes a particular way of thinking about your facility. So instead of having static production lines that are designed that way from the beginning and are that way for specific products, and you have to retool it, etc. You kind of design it at the very beginning of the life of the plant, and it's that way forever. In MTP's world, you basically would have sort of these modular skids that machine builder has an MTP compatible machine, which in MTP they call process equipment assemblies. So if I say the word PEA, or then that's what I'm referring to as machines. And when you plug it into the plant, there's supposed to be a concept that doesn't exist in most manufacturing plants today, which is what they call a process orchestration layer. And the idea is that you can plug the PEA into the plant network, and it will automatically communicate its capabilities, its constraints directly. The way to communicate it, it will even draw the HMI for the process that's relevant for that PEA, for the process orchestration layer. And what that enables the process orchestration layer to do is to then add it to its sequence of what it's trying to do. So if it has a particular sequence of things it does involving specific, what they call services, so it's kind of a rethinking. Instead of thinking about it from a machine perspective, you're thinking about it in terms of, in the facility, I have available to me these services for either the facility or the product. When you add a new,
So it's kind of like a Docker container for your equipment.
It's a good way to think about it. I definitely think it's a good way to think about it, because it even declares things the same way Docker containers do, which is that you're declaring interfaces for an orchestrator of some sort, whether it's Docker Compose or Kubernetes or whatever, and how that Docker container can be used, how it communicates with other Docker containers, like, for example, what ports are forwarded through, what volumes it's attached to. So I actually don't have a problem with that description of it.
Dave, what are your thoughts? I know I have a ton of questions for Caleb.
No, we all agreed that Vlad had to go read the entirety of the MTP overview V1 before he was able to go ask any more questions in this episode, or maybe any episodes. I don't know. We'll see you in about 3 weeks, Vlad. But no, I have, I guess, for everyone in the chat and in the comments, sent some information on MCP. I'm looking for something good on MTP. And I think Caleb has a couple valuable things. I guess my issue is every time I go to direct someone towards it, all I see is a laundry list of mostly German engineering companies who have all written, their blog posts or their website posts in which they're going through and talking about it. So it's hard to go find a definition of what MTP is. It's hard to go find a definition of what MTP is that you can go and share, which is sad. Absolutely, which is sad.
And again, I'm going to muddy the waters still further, because the way that all of them explain the value proposition and the reason why you do it, I do not agree as to what the most valuable short-term actionable value it has for manufacturers is today, as how it's typically described.
And yeah, I was going to say, I think that is a good segue to as you were talking about it, Caleb, you have thoughts on how you think it could be best used more than just a interchangeable hardware software standard for some of these large companies. Can we get your opinion on what you think the major value proposition is moving forward, please?
The major value proposition from my perspective is that and I'm gonna predict a little bit into the future as to what a real adaptive plant would look like, really actionably, what would that look like? So in the real world, people will think about a use case that I hear a lot is people for whatever reason or another, they at least conjecture or are actually want to have an AI model write back set point changes to a PLC or control system. That's a common thing here. And there's lots of business reasons why you do it, whether it's production optimization or defect detection or whatever. But in the actual real world, because you have a limited number of drives and valves, and you might have, it might actually be, actually, I will say that this is actually how it's worked that I've seen, is you would actually have, especially if you're modeling off of, say, autonomous vehicles, you actually have AI models that serve specific purposes during specific states of the machine. You don't just have one monolithic, glorious AI model solve all models, and even if you did, it still has to interoperate with the operator. So, what does, and this is in the scenario I like to give people, maybe I said this in the previous episode, so I'm sorry if I did, is how does an operator who is remote override an AI model who's on the edge, who's local, in set point changes? Okay, so yeah, Davey's commenting. Davey's right. He and I talk about this a lot. So I don't even know why he's here.
Caleb's scaring away the viewers.
He already knows my stance on this. So in a world where that's true, in the real world where you have an operator and maybe 5 AI models, some are running in the cloud, some are running on the edge, some are running different places in the plant, and each has a different role and they're in a different state, you have to have some way to orchestrate these. And in particular, at least in my belief, you need a universal layer that communicates universally to all AI models and all humans together. What are the states of the machine? What are the capabilities? What are the things that you can do for it? Thanks, Davey. What are the things you can do for it? What are the things that you should expect from the machine? How do you have sort of a universal understanding of what's going on across all things? Now, what's the state of the machine? What can you do right now? What can't you do right now? What's safe to do right now? Now, to a certain extent, one could say, and one would be, you could say, a universal answer here is UNS, right? The UNS is a way to describe your whole factory and all the different data. But within the context of writing data back to a machine, you need another layer. You need another layer that goes even more specifically into the ontology, particularly around machines within UNS. So now, and if you're a fan of OPC UA, then that is interchangeable with UNS, if you will, but MTP is something that you need regardless, because it is a data model that goes even beyond that. And there are state machines built into MTP, so it's not just a data model. It's actually there's actually some things inherent to MTP that are very, very important. So going back to the world in which I'm predicting, in which I believe that there's going to be multiple AI models need to be orchestrated with humans, in a kind of who's got control of the valve right now? In what state is it okay for somebody to have control of the valve right now? You need some layer, if you will, that separates the control system from AI models, because one of the other elements to AI models that's really important is AI models are fundamentally stupid in a lot of ways. They're fundamentally unique, work really well in a specific state under specific conditions, and not very easily transferable, at least in current technology. And also they're iterative by nature. So data science, you should expect to fail. You should expect for it to be bad. So one of the things I see in manufacturing is the way that they solve this is they try to make it an AI model solve all use cases before they ever put it into production. And then it either never gets put into production, or it gets turned off real quick because it still misses some edge cases. So, and I don't view that as a sustainable thing. So MTP. So I had originally set about to inventing something myself, which was basically to solve this problem because I saw it coming starting back in 2016, 2017, as something that people would do, and is becoming more and more prevalent. And then once I saw a module type package, I was like, okay, I'm going to stop trying to solve this problem by myself, and just leverage MTP for this use.
I obviously have a lot of comments on that side, right? But playing a little bit maybe devil's advocate. So a couple of things. Number one, I guess the concept you're describing is not new, right? And you've mentioned a couple of alternatives, whether they're better, worse, different. That's a whole other debate. I would also add that I'm not sure that this has started as a result of the push towards AI, and I'm not sure that a lot of plants, at least in the Browns, would be able to rationalize, hey, we need to add this layer, and which basically requires a ton of re-engineering work. So I'm curious, maybe, how would I say it? What's the, I guess, if we go back to this value add for someone who's maybe not seeing AI as the main path, right? They're seeing maybe something else where they need to pull in data into more traditional systems, but also they're looking at other alternatives and maybe even like custom built systems. And as you know, and we've discussed this a little bit at the beginning of the stream, food and bev production is vastly different than, let's say, oil and gas, right? So whether or not you can actually wrap, let's say, a skid that is replicated, let's say, in oil and gas versus, in food and bev, skids are custom to process, the process is custom. I'm just curious, maybe, is it really as universal as you're describing?
I contend that it is, because at the end of the day, MTP is all valves and drives. And and if you find me something doesn't boil down to valves and drives, I'll mea culpa. And but so long as manufacturing ultimately is about motors and valves, I will continue to think that MTP is a universal concept. Now, you are correct that that most facilities are not MTP ready. The way that I can say that at least Siemens has solved this is as part of their industrial edge product. They've got an application called Machine Proxy app, which basically does this mapping from your current PLC way of thinking to MTP compliance. I believe that there's other systems that do it. So it's possible for brownfield plants to do this without changing their PLC code or anything. And I think that's a very important concept, obviously, because if I tell you that you have to revamp your PLCs to do this, then of course you're not going to do it ever, right? So I wouldn't even be talking about MTP if it required a total refactor of your entire control system to work. So there are ways to go about enabling it. The only thing that you have to do to make it work is really you have to stop connecting your SCADA directly to your PLCs and instead connect it to the edge computer running Machine Proxy app or whatever. that's the big rule, is that you no longer are attempting to do this directly to the PLC.
Okay.
That's the one, I would say, that's the one big thing. So like you said, this isn't a new thing. A lot of people have been wanting to do that, leverage AI in this way since way before that. It used to be deep learning, and it was neural nets, and it was Bayesian methods. We've gone through a lot of different expert systems, gone through a lot of different types of guidance technology or autonomous technology over and above the control system. Advanced predictive control, model predictive control are all over and above the PID loops that make up your lower layer system. So it's not like this is a new thing. The difference is that the more we realize that layer needs to be able to upgrade over time, like if new technologies increase or that you need to have some kind of stability at some layer. And so I would contend that ultimately, running AI successfully, particularly with a lot of the networks ultimately requires edge computing. If you have edge computing, then you can do this as well. You also can, on Greenfield, do it directly with the PLC without having an edge computer. And I think all the major manufacturers have libraries that help you with this. I know Siemens does. But if you, like you said, in Brownfield, that's not a reasonable thing to ask, and nor am I saying that you should. So that's how I skin that cat. That makes sense.
I would say, and let me throw like one last question at you before I pass it on to Dave. But I'm curious again, if I approach an engineering manager or director again at a brownfield facility, because that's just my work and what I've been doing a lot of. I need to be able to clearly articulate to them, what value they will receive as a result of, let's call it install some edge devices, which I would say are marginal, but ultimately, I need to make sure that the pipelines are correct. I need to reconfigure their existing SCADA. Usually they have a SCADA. They probably are, I want to say, in the gray area when it comes to, let's say, a historian or an MES system, or maybe it's very legacy, historians and MES. So there is an opportunity perhaps to standardize that data flow. But I guess, how would you pitch it to someone in that position? Because again, it is not cheap to, I would say, buy. I don't think you need a lot of edge devices, right? You could probably run it on a server in the grand scheme of things. But really, I think it's the engineering hours and sort of the reconfiguration of the SCADA layer to make sure everything's working well before we can even put anything on top, right?
So I'll take it from a few different angles. So the value prop for any of this from a short-term thinking perspective is usually always that there's some return, whether it's increased production, decreased uptime, decreased defects. Everyone knows the problems they have with their current system as it relates to the very manual ways that they catch problems on the line, the very manual ways that they debug issues on the line or the machine. So everyone knows the problem. Now, I haven't yet met anyone that thinks that they unequivocally will be in business in 15 years if they ignore AI. I haven't met anyone who would say that they believe that's the case. If you find them, then let me know. I mean, I would be interested to see kind of like, I think maybe refineries downstream, because they're the ones who, they refresh their DCS only every 20 years anyway. So, but for most people, I think there's a general consensus, even if they don't always know the business case yet, and a lot do, but some don't. Usually the ones that don't are ones who haven't even bothered to connect their machines up anyway. So this whole world is not really for people who are still struggling to get their machines connected in the first place, right? So, but the great AI is one of the great equalizers. So a small manufacturer can compete with a large manufacturer if the small manufacturer is more agile as it relates to the adoption of technologies. I would contend that there's going to be a lot of people that will be out of business that are ignoring AI in 10 years. But generally speaking, I haven't met anyone below, at least in the, and AI is an interesting one because it is and by AI, I'm using a blanket term for a lot of technologies, but AI is an interesting one because it is the first technology I've heard to be deployed in a control system or in a manufacturing plant where the CEO is asking for that technology for that technology's sake. Like they don't care necessarily who the PLC manufacturer is. They don't care who the SCADA is. They may know who makes the ERP. But AI is the first time that I have seen companies saying we want to do AI without knowing the business case. So if someone's asking you the business case for doing AI at all, then it's probably there's a lot of literature out there as to the things that you can do with it, you should do with it, and the problems that it solves both in other industries and is proven for manufacturing. So I don't want to get too specific just because I rob it of some of its power just by giving it, like 20% increase in production. Sure, that's icing on the cake, but actually you probably won't survive as a business if you haven't. If everyone else in your industry is adopting it and you're not.
Maybe I need to refine my pitch and just just sell them on AI.
I mean,
but
I mean, there's a lot of very linear thinking people out there, and for linear thinking people, it's best if you have a. Well, I have these 3 case studies of these organizations that have increased their production by 20%, or we're like that exists, and there are examples of that. The problem is oftentimes when you provide those case studies, people who are linear thinkers can say, well, maybe that doesn't apply to or maybe with my economics, that a decrease in uptime doesn't really mean that big of a, like there's always reasons. My main argument is that if you're not thinking about it, then it will be difficult to stay competitive with rising costs and workforce issues, and not even considering, particularly in its current state, what AI can do for you.
Yeah, I'd be curious to hear what Dave has to say about this, right? Because for me, I've always had to justify, certain budgets and expenses. I cannot just blindly say, "Hey, we want 2 million or 5 million to implement this because of AI," right? It has to at least have some sense of, in a year or in 3 years, we're going to have this ROI because of XYZ. So perhaps maybe, I'm not talking to the right people, but it's always been a business case justification as to when can we expect to get a return on what we're putting in, right? So I guess the way you're describing it's a little bit different than what I'm used to, at least.
Some of it's a timing issue. Go ahead, Dave.
No, I was gonna agree with what you're saying, Caleb, because I think a lot of it is a timing issue. And I think the concept of AI, and I think a lot of what we're selling now, the previous part of the conversation was standing, is we're selling the concept of AI, or we're selling the foundational steps that will go bring us to actually being able to use whatever this quote unquote AI solution is in the next 6 months or in the next 2 years. I don't know very many groups who aren't and have not been using machine learning or regression algorithms for years and years that could, in theory, go drop an AI solution. And for our listeners at home on podcasts, air quotes, AI solution, there aren't very many people that can go drop those in today. Having said that, I think that the AI taking the world by storm, taking the media by storm. We've got boards of directors and C-level executives who see, I don't know, the Dateliner 2020 talking about ChatGPT and how everyone should go use ChatGPT and how it's going to reduce all of this workforce. I think we see that as a generational and transformational potential shift in which we're less worried about the ROI today as comparative to the we want to be a business still 5 years from now, 10 years from now, to Caleb's point. Having said that, I think that's the direction we see people going. I don't think that there are lots of people just opening up the checkbook and investing millions of dollars in a lot of these projects. But I see this as a potential to have lots of people invest millions of dollars, especially like even medium-sized organizations are investing millions of dollars because, to Caleb's point, they still want to be a company 10 or 15 years from now. Now, I will say, Caleb, I think the companies and the organizations that are unwilling to change for AI or who are unconcerned about the concept of AI on the uncarpeted parts of the floor are the sort of companies that don't care about the concepts of digital transformation of Industry 4.0 and to a large extent Industry 3.0, right? There are lots of companies out there who, to Vlad's point, have no networks, who have no systems, that they're a bunch of standalone machines. I won't make the comment as to who it is, but I've heard from him, he's gone in and, down the street is a group that makes boxes, right? And I think all of us has a company or several company that make cardboard boxes, not even like as a metaphor, like literal cardboard boxes. And man, they've been punching out these same cardboard boxes on these very mechanical machines for 110 years. And they're going to go continue to punch out the same size cardboard boxes or trays or other things on these same machines for another 110 years, unless something changes or the machines break or they're forced to do something different. Right. I think when we talk about this transformational shift and having to forcibly reduce overhead costs and labor costs and things like that, that is very much potentially the shift that we're going to see some of these other companies care about. But I think there's probably the bottom, I don't know, we'll call it 10, maybe 15% of organizations who are like, we don't want sensors. We make boxes or we make widgets or we make whatever this thing is. We've been doing it this way for 100 years. We're going to continue to do it this way because the cost of upgrading from a very dumb facility to a AI ready facility, or just even more than a couple of point solutions worth of data collection, is an enormous cost, right? Like these groups may physically not be able to withstand the cost of going down that path.
And like I would contend that we're in what we would call a time of change. There's a really great quote that I would say that it's in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. That's like basically, I am not a good person to talk to people who just they don't even see the value in sensors. So that's a world that I can't exist within, and so that is a group of people that will never ever like me or want to talk to me, and I'm fine with that.
Yeah, Caleb still does not exist in the dimensional plane that involves those organizations.
That's correct.
Yes. Take a drive to Pennsylvania.
I was going to say I did hear what you said earlier, Caleb.
I know this is a thing. Is a thing.
I would say, look, ultimately the three of us agree that there's value in AI. I think like what I'm questioning a little bit, right, is in these conversations, how much is reasonable to make an ask for, right? Because again, just saying, hey, we want to modernize so that we could leverage AI, obviously there is still a question of, do we put that money into this or something else? And the question becomes, if it's $100K for a facility that makes I don't know, $10 billion a year of a business, fine, that's nothing, right? That's a drop in the bucket. But as soon as that number starts increasing, which again is, I guess, undetermined at this point, then it becomes a harder sort of commitment when the ROI is not clear, right? So I think that's where we maybe are trying to figure out the answer.
So you're absolutely right. So, I would say that the best salesmen that have to exist are people who are intrinsically motivated and want to do initiatives within their own organization. They have to be good salespeople. And effective. They have to, so one of the tricks to sales is timing. And so what I like to do is I would say to any automation manager who's struggling to, and I've seen it. I've seen all over LinkedIn, like people trying to convince their management to let them buy SCADA, things like that. I've seen it. I would say rather than focusing myopically on just the technology, you should also focus on organizational psychology. I like to say that technology is 90% organizational psychology, because the truth is that all the technology that needs to exist is at your fingertips today, just in open source libraries of stuff that's free. Anything you could possibly imagine is ready for you today, an organization today. So a lot of it has to do with how well you can talk to people within your organization, and like I said, part of that's timing. So if you think you want to adopt AI, just wait for the CEO or the operations manager to solicit ideas for modernization, or to specifically say to you, which I want to do AI, let's build a task force and do it. Now, if that's not happening, if your executive management doesn't want it, I wouldn't even bother. I wouldn't bother, because the problem with hierarchical organizations and leadership is that if leadership doesn't see the value, then no one else will, or no one else will be able to convince them of it. So I would contend that yes, there are you could do all sorts of complex, business cases and ROI evaluations, and can do your own pro formas to convince your CEOs, like as though they're venture capital investing in you, the business, even though it's their business, right? So I would just say, if you're someone who's struggling to do that in your business, move on to another business. If you really want to do this stuff and the company that you're with is not interested, then there's no reason. You're only going to be made miserable by staying. So I guess I don't think that I would say there's nothing worse than a controls engineer whose spirit has been broken.
I think factories are filled with those.
Right. No, I know. I know. And it's the saddest thing to see, because the people within the IT/OT sphere, whether it's, that are at that edge of, from sensor selection through deciding what operating system goes on the servers, these people, and what network equipment, these people they should not allow themselves to be broken by an organization that doesn't appreciate them. So
that's a tough ask, Caleb. That's a
I know.
very tough
Listen,
ask.
I've been in this business. I know, and it's always disheartening when it happens. But if I were to give any kind of advice at all, career advice, it would be just don't focus so much on trying to convince people that don't understand it. Most organizations at this point understand the importance of modernizing your infrastructures. Now, they may not want to focus on the same thing first. I've seen CTOs of companies have really bad networks and want to move everything to the AWS, but how are they going to get to AWS because their networks are bad? Like, so you will have management that doesn't understand the order of operations, and that's for you to communicate. And that's one of the sales pitches, is that when they come to you saying they want to do this thing, like they want to do AWS or they want to do AI, then you would then tell them, here's all the investments that hadn't been made up to this point. That's a necessary investment in order to really do a good job of moving to that point. Because
yeah, it's interesting how you put it, right? And I had some thoughts actually a couple of days ago after having spent a few days at a plant where basically, as you've mentioned, the engineers were broken. And, to some extent, my realization was that I'm not only fighting this OT and IT battle, I'm also fighting the plant teams because they're convinced that everything was better on Ice Cube relays. And anything that has to do with a plant-wide network is just, how would I say it, is just not good or not good for their specific facility. So I think it certainly resonates what you're describing. I'm not sure we will solve that challenge at scale. And for sure, as you've mentioned, probably a lot of businesses will go out of business
yeah,
as a result of not being able to like wrangle those people or organization, whatever that looks like.
it'll solve itself, because I think that the generation I'm a part of, the millennial generation, is the first generation that even remembers time before the internet. So I think that trying to explain to someone who just graduated school, like workforce that just graduated school with, experience in, whether it's an operator who has, thinks about apps, or it's a software engineer who thinks about Python, that this problem will solve itself, because companies who are still doing ISQ relays in 2028 will be in trouble, or they will be nearing, like, basically what I would look at is, when the people who want the IceCube relays, when will they retire? When they retire, that is likely the moment when this will hit pretty hard, because when they try to backfill them with someone else who will want to mess with the IceCube relays or Windows XP, then I'm picking on Windows XP.
Oh, we've got Windows 98 over here. Windows XP is way too advanced.
We miss Windows XP, Caleb. We miss Windows XP. Windows XP was the height of automation software technology. But no, I guess I just like to comment on maybe the most interesting piece of career advice we've ever gotten, of the difficulty of organizational change. And at some point, you have to decide if these are the things you want to do professionally. You have to leave. And I think it's really good. I think it's very good advice. Vlad and I have talked maybe a little bit on show and certainly off show, is that there have been several places that I've worked in the past. And at some point you realize this is the most you're going to get, right? Like, these are the opportunities you're going to get. This is the technology that you're going to get. They have no desire to go beyond the comfort of what they've been doing, because this is what they've been doing. And you can either go continue to pitch upward of, let's go do these other things for reasons. And maybe there's a business case. Sometimes there's not even necessarily a business case immediately. But at the end of the day, if that's where you want to go professionally, it's important to realize that you very well may have to go to an organization that wants to do that and is looking to bring in someone who wants to do that. So I think that's a very important, I think it's a very important statement. And I just wanted to make sure for all of our listeners out there, that we kind of continue, and finish that thought.
And I would say, if you think that you're going to be doing the same thing for the rest of your career, and that you'll be able to ride out the rest of your career as it is, if your career goes beyond another 5 years,
Yeah.
I would contend that you probably are not safe with that assumption. So even if you are comfortable and you do like the technologies and you don't want to advance any further, and I would say that's not a safe stance to take.
That's a bold statement. I feel like I can program PLC 5 till the day I die, but that depends, I guess, what you're doing.
I think you could program in ladder logic. I don't think there will be PLC. I think eventually all of the PLC 5s will be gone because they'll just have stopped working. As the PLC 1s and 2s and 3s before them, at some point they will all just stop working. Like, how many PLC 2s do you see anymore? Nearly none. The PLC 5s are not that far behind. But no.
You're right. There's a long tail, right? So there would be. So the statement I made is that it's not a safe assumption. It is. There. You're right that there will be people who, there will be people who will want to deal with the legacy long tail of manufacturing. I wouldn't be surprised if the way that these things go out of service is that the companies who are still thinking that way, like, I'm not going to replace my infrastructure and therefore nothing above it, might just go out of business entirely, and all the PLC 5s go with it, right? So that's a way that it happens versus just the PLC 5 failing. In some ways, I would say it's likely the business won't outlive the PLC 5, but one way or the other, I think. Yeah, you're right. There will be good money to make, I think, just doing PLC. So I guess
let me ask, I guess, a more tangible question before I pass that on to you.
Perfect.
So looking at MTP, right? So we've talked a little bit as to where it lives, right? It could be on the edge or maybe in a greenfield application directly on the PLC. But I guess for someone who's looking to maybe understand a little bit better, what does it actually take to configure and set up, in a proper way? I guess maybe to some extent in both of those scenarios, but I would say more leaning towards an existing manufacturer. Hey, like, we're interested, this sounds interesting. What are the next steps to at least try something, maybe even just an MVP, to see if we like something like this and it makes sense for us?
The next steps is I would pick a machine, and I would just a machine from your business, and especially one that you think so, and you can either decide to, maybe it's a machine that is a stick built machine that you have. It's not made by a machine builder. Something, a lot of companies have like machines they've had to make. And so they have a PLC program running that they've developed themselves. It wasn't made by the machine builder or anything. And I would, say find a vendor who offers one of these machine proxies, if you will. There are a few. I can list them all out. Like I said, Siemens is called Machine Proxy App. It's part of Industrial Edge. And I would just go through the process of actually doing the mapping. So one of the great things about a lot of these softwares is it kind of teaches you what MTP is about while you're doing it. So if you like, I can share my screen just to show you what this actually looks like. Okay. Mm-hmm. So I'm just going to show.
And I would say, obviously, for anyone listening, this might be a little bit difficult to catch. I think if there's interest, right? So if you're watching or listening to us right now, and if you're interested to learn more, either we'll obviously share the links where you could also take a look at this, but maybe we can have a longer session with Caleb doing like a full-fledged, share screen demo in the near future.
I'm trying to not make this an Industrial Edge pitch. So, but I'll just give an example. So, so here we have a fractionation column and the purpose for this one is to depropionate butane, if you will. So, so the way MTP is organized is you divide what capabilities your machine has into what they call services. So here I've got a feed control service, a heating service, a reflux control service, a pressure control service. They're all services. they're ultimately mapped to what they call here drives, but it's basically any valve or drive. So here's a binary valve, i.e. an on-off valve. Here's a control valve. So here's an analog valve. So this is the way that machine proxy app conveys it. But basically, there are really specific interactions. You can think of these as tags that have logic behind them, or you can actually think of this whole block as a function block, if you will. That on the right side is the logic coming from the PLC that you're going to map to make MTP compliant. From the left side, you see that there's an arrow going from process orchestration layer, is what you expect to come from the process orchestration layer. Okay. Now, when you're actually doing the mapping, what you want to do is you want to understand what each of these things is, and then map the way that the PLC currently thinks about that to this. So a good example is the what is the called the state automatic activity, which is what turning the automatic mode on or off, which is the same thing as saying an operator doesn't have this in operator mode, is currently taking its logic either externally from the process control orchestration layer, such as through an AI model or whatever, or internally just logic that's in the machine. Okay. So in your PLC, you might have different tag names. You might have different ways that it is conveyed. But here in MTP, the way that it's conveyed is that it's a series of bools that's organized into a double word. So in each position shows a specific one. So like if one flag is up, then it's and I'll show a state machine that shows this in a second. One flag is up, it's in external mode. One flag is up, it might be an internal mode. If another flag is up, it might be an operator mode. So those might be different integer values for you in your PLC. So what you do in these types of run times is you're mapping it to the way the MTP thinks, and they're kind of teaching you the way that it thinks by the. So here's a good example. The way this is a double word. The way that it's depicted in MTP is that the bit number 0 is not used, bit number 1 is not used, and bit number 2 is stopped. Now that might be a specific tag for you that a particular service or is stopped, but in this case, what you do is you map that tag into that bit position integer, and then now you've got the mapping through to your PLC logic. So that's I rather than go, get too prescriptive, it's better for me to just say that if you want more information about how to do that, then about what that would look like, it would help to get more specific into your PLC program that you're working on. But there is a way that MTP thinks. So as long as you've mapped your things into how MTP thinks, and so the way this works is it gets the data by this is an edge computer that sits directly next to the PLC. It pulls the PLC directly. Those variables come into here, and you can map those variables. So, for example, you can literally map the variable directly, or you can map the logic. You can turn it into a script. So it's work to do, but the benefit of having done it is that if you do this work and you actually map the way that the way that it was developed by someone else, or the way that it's developed by yourself in a previous lifetime, this is a good methodology for you to normalize these things so that it can automatically interact with other systems. Because you can't know is how you would make your own PLC code to guarantee that it will work with another another machine or an AI model that was developed if you're not doing it against the standard. But if you're using a standard like MTP, then you can know that multiple manufacturers will support it, that it will work dynamically with other systems. And in this case, once you've done the mapping, you can actually, MTP kind of takes two forms, the active runtime or as a static file called an MTP file, kind of works the same way as like a GSD file, GSDML and Profinet, or an IODD file and IOLink, which is that it communicates in a way that the other system can parse and knows to parse it to then, to then automate its capabilities. So in this case, what happens is once you've engineered it, you can actually, oh, there's no project. Once you've engineered it, there isn't a project. You can load it into the runtime here or simulate it, and then it will run kind of on top of your PLC. It actually generates an OPC UA server is what it does. And
Gotcha.
now you hook to that. And all of the tags that it shows are then represented that way through the OPC UA server. And if you then drive it from the other side as a command via OPC UA client to a specific parameter, if you drive it the way that MTP works, then it will then translate it into the way your PLC thinks. So that's how you handle the variability involved in MTP. And like there's a lot to understand with MTP, and I think that's actually its great weakness. MTP's great weakness is that it's complicated to understand conceptually. But if you get the hang of it, I personally think it's one of the better methodologies that exists for managing complexity, but it of course is complex. So you can't be afraid of understanding something deeply to make it work, like some things you can.
Could you tell me a little bit more as to who currently maintains the standard, right? I feel that depending on who the group is and who's involved and sort of leads development, it how would I say, it brings different nuances to the entire project. So is someone actively working on expanding MTP and I guess maintaining it, maybe creating templates,
It
etc.?
just got turned over to the Profinet Association.
Okay.
So it is now, like IOLink and Profinet, it is now part of the Profinet Association. So that's what I would expect to maintain it going into the future. It was originally developed by the Society of German Engineers. It's called VDI. And I think that they realized that the scope was significant and would require the same kind of maintenance that a standard protocol would. And so that's who has it now.
Gotcha. Makes sense. Dave, what are your thoughts?
I am really happy that Caleb said that Profinet has now taken over MTP, if only in part because I was just on the VDI website desperately attempting to go look at the standards, and even on the English translated version of the website, it feels like it was written definitely and only by German engineers. So I think all of it is really interesting. We will go dig for the MTP doc, any sort of doc that we can go ahead and share, or any sort of doc that we can go ahead and direct people towards buying, because I don't know if it's one of those that you can get for free or if it's one of those that have to be purchased. But before we let Caleb go kind of comment on that, I think this has been super interesting. I think machine proxy in and of itself it's very, I don't know, I'm going to use the word interesting once again, but I agree something like that is going to be necessary, right? We've always talked, at least on Manufacturing Hub, about needing some sort of normalization layer. And I think MTP as a structure and basis and backbone of that normalization layer makes a lot of sense, if only because it has the backing of so many large OEMs and the structure and foundation to go be able to leverage that as your orchestration layer for the different AI tools that you're going to go bring into your site in the coming weeks and years. Having said that, I feel like we're 70 minutes into a 60-minute conversation, and we've barely scratched the surface. We have, I think, 90 to 80% of the way defined what MTP is. And why people should go use it. So we'll have to go find some more time later to bring you back on, Caleb, to go maybe fully flesh out the MCP as the safe basis of AI in manufacturing. So thank you so much for that. This has been a ton of fun. We do want to go ask you all of the questions we ask our guests at the end of the conversations. Having said that, I feel like you absolutely already gave us the career advice piece. So thank you so much for that. But the question that I like to ask all of our guests, and the question that we like to enjoy so much, is asking about predicting the future. So I guess give us the AI prediction of the future in the next 2 to 3 years within manufacturing, please.
So I would say it's going to continue to move towards. I don't know what I would say open standards and open systems, and therefore I think you'll see more success in products that, like, for example, have an MCP server in it than, say, a product that locks you into a specific LLM. So, like, right now, what you're seeing is a lot of products with, like, their own copilots or their own things attached. I think you'll see more. Now, I'll separate into engineering and operations. So in engineering, I think that the per system copilot makes a lot of sense. I think in operations, you will want not tied to a specific or an only system, or but that you would want to be able to plug in new. So the AI technology is continuing to move at a faster and faster pace. So, like, some of the ways that I would have talked about it at the last podcast that we've had, I would say are now obsolete, now outdated, things I've said then. That's how fast this is moving, because it hasn't been that long, right? And I think, LLMs will become obsolete. Gen AI will become obsolete, the way that they currently think of it. And it depends on who you listen to in the artificial intelligence space as to whether or not, the next one will be large reasoning models, or something Jan LeCun comes out that totally invalidates the whole method of technology. Because at the end of the day, all of these are based on mathematical precepts where the underlying foundation of the math can change. So a new way to process data and find patterns can completely invalidate an entire line of thinking. So I would say the only prediction that someone can give you accurately is that it will absolutely change, and that things that I'm saying today will be obsolete. In fact, probably, most certainly before my career is over, possibly before I finish the end of this sentence. So that's the one constant, I think, is that that's not much of a prediction that things will change. I think probably the biggest prediction is that don't think that LLM technology is the end game, I guess, is the best way to consider. So when we talk about manufacturing, obviously manufacturing tends to be behind. I actually will make a bold prediction here, where I think that manufacturing will at some point leap and start taking a leading role in terms of the types of intelligence, because as more and more of the manufacturing community becomes really good at this, we'll have a really strong understanding of how it works in disparate scenarios, which will give us a broader aspect. So I think that there's actually areas that we're currently behind in technology that will actually leap ahead of the rest of the group, and we'll start being the pace setter for certain types of this stuff. And I think that's probably the more bold prediction.
Absolutely. No, I think that is. I think it is a bold prediction.
It is.
I certainly agree that there will only be change.
You traditionally would think that that's not going to be the case. That manufacturing will be the last to adopt, but I think that's only because of the times that we've been in like the last 20 years.
I agree that there are more and more companies who have been collecting this data, and I think some of the largest companies in the world who are going to spend hundreds of millions and billions of dollars, or groups of these organizations that are going to spend billions of dollars, will be manufacturing industrial organizations. Otherwise, they won't get the solutions built that they want and need. So I would agree with that. I think at some point, these large organizations, or these large groups of organizations, will have to go put their money up in order to go down that path. So that is interesting. Having said that, some content recommendations. I know we've talked about some standards. Do you have specific places that you would suggest people go look at the standards? Do you have other suggestions of other content to read? What do you have for us today, Caleb?
I would say, if you have, I think the last I looked, it was like 150 euros, and you have any desire to read a standard at all, then you go to VDI's website and look at version 1, because even when Profinet Association comes out with version 2 or whatever, it'll still be fundamentally, it won't be so different. That's one. I think that that would be the specific literature. I think more broadly, I still really like the, I suggested How the World Really Works as a book by Vladimir Shmil. He does a really good job of covering what the pace of innovation would look like, or what predictions you can accurately make, particularly in the fundamental technology. So I think in manufacturing, it's a particularly important book, and everyone should read it. And besides that, I think there's increasingly a lot of good literature, and I'm trying to think about anything specific I would tell people. I guess you can just message me if you want more specifics. People never do. So
it's a safe ask.
Yes.
Let me ask you a wild card question, Caleb. So as a fellow entrepreneur, I'm sure that you're not short of interesting ideas in our space. So the question is, if you were to, I would say, build or recommend someone to build an interesting piece of technology, whether that's, software or hardware for our space, what would it be?
Well, I would say there's continuing to be, I think that the novel sensors we're back to that being an interesting area. So for a while, sensors were less important, and it was more the software you sprinkle on top. But as the software changes and the ease with which you can create software changes, and people can now use LLMs to generate their own code and all those stuff, the importance of bespoke software that you can go sell to everyone is going to go by the wayside, and it'll become back to being more hardware centric. So I would say IO-link sensors is one.
What would you want to see in that, I guess, sensor of the future? Like, why sensors? Do you think there's challenges in sensors?
Well, because the truth is that sensing technology is always behind physics, right? Because the people who make sensors, once you've designed a sensor, usually you don't want to make continual investments, and so they'll just sell that sensor for as long as they can get away with it. And then there's other companies that are continuing to evolve sensors. So, but basically, you could go to, for example, you could go right now to NASA Technology Transfer Program, and in it, they will have designed a sensor for use of space that they'll say, but we would like to license it to somebody for the purposes of using in, say, manufacturing. And they'll even give you the use case for it. They'll say, this would be good for this scenario. And they give the design. And they say, if you're starting your company specifically to do this thing, we'll give you the design and all of it for free. So you could basically have NASA do all your R&D, all your design, and you could literally take that and have it manufactured by contract manufacturer. So it's not like as expensive as it may sound, what I'm describing here. You could do that a lot easier than anyone was ever able to do that in all of history. It used to be the sensing, building hardware was unapproachable to most people. But now with things like Flux AI and generative AI it's getting easier, but the market hasn't realized it yet. So it's getting the bar is lowering to entering it, and there are things that you have to know about, but generally speaking, people in manufacturing do know. Like if you're in oil and gas, the one requirement for any sensor that has to be within 10 feet of a wellhead. It's class 1 div 1 or zone 0 is HAZLOC, hazardous location, right? Mm-hmm. If you're in grainers, that it has to be. So in our groups of people, we know better than anyone what a sensor has to be able to do, what the environment has to be in specific industries. So that's what I would call an interesting idea. The other one is there's if you're talking about making a product or if you're offering a service. When offering a service perspective, I think right now there's a lot of money to be made in helping people implement UNS, for example, because it's a lot more popular than there are people who can set it up. It also is approachable enough that it can be maintained by the on-site staff once it has been set up. So I'd say that's another one. The other one is there's lots of interesting technologies that could be built on top of graph databases. There's all sorts of things you could do that fall along the entire value chain without being, because the hard part is not really developing or building a product. The hard part is getting it validated and making it relevant before it becomes obsolete, particularly if it's software, right? So that's one of the reasons why I went straight to hardware. You will have a longer window with which to validate it before it becomes obsolete.
Yeah, of course. I think it obviously has trade-offs, right? It's also requiring a more significant capital investment, depending how you look at it. Of course, you can prototype on the cheap.
I've seen some guys out there that are really doing a good job. There's that guy Mr. IoT, who made the shark things.
Yep.
I doubt that he was able to put a whole bunch of capital into developing it. He's just a really smart guy and developed an interesting thing and had the idea of
Chris Mitzer.
Making it work directly with UNS broker, and that was obviously interesting out of the box. That's interesting to people even before you look at the use case. And so it's like a sensor interface on one end and MQTT on the other, and so that this, and you don't even have to worry about processor architecture or whatever. You can base it off of a Raspberry Pi compute module or an Arduino or whatever as the processor. You don't have to be an embedded software engineer to do it anymore. I think that there's that's, I'm just saying the reason why it's a good idea right now is because most people hear that idea and immediately think, oh, that's too hard. Mm-hmm. That means that 90% of all people won't even consider doing the research required to start a business like that. So for those
of course.
So they say in product development, you're either a snow leopard or you're a lion. A lion, you are in a target-rich environment, but also there's tons of competition, tons of other predators. A snow leopard, there's not as many opportunities, but there's a lot less competitors as well. So you have to pick your hard, really. Either it's going to be easy to do, and there's going to be about 1,000 people you don't know about that are in different stages of developing the exact same thing you are, or it's got to be hard, and it's got to be harder, and using people's belief about what is hard or easy to do against them. And so I like both approaches personally. I like it when it's a unique thing that doesn't exist, that doesn't exist and probably won't exist for a while.
It's a good way to think about. I guess it is a lot easier to just vibe code some apps using ChatGPT, but yes.
Yeah, it is. But now you know that everyone can do it.
Yep. Yeah.
Absolutely. Interesting. Caleb, thank you so much for this and for this conversation. Last question for you is, how can our listeners help? Who should reach out? Who are you looking to connect to? Those sort of things.
Oh, I'd say if you think like Davey, then definitely reach out. I mean, basically, I would say if you're interested in this topic area, this is what I consider to be my passion area, the interface between AI and control systems and doing it safely. So anyone who's interested in that is probably within the scope of, even if you think that MTP is not, or especially if you think that MTP is not the answer, I'm interested in your thinking.
Awesome. Caleb, thank you so much. This has been a fantastic conversation. If you guys are watching live, make sure, and especially if you're watching on LinkedIn, which is where most of you are, make sure that you're connected with Caleb. Make sure you're following Manufacturing Hub as well as Vlad and myself. Stay tuned for next week, where Vlad and I are going to go work on putting all of this together into a couple of examples of how we go connect everything, and probably not come out with quite nearly as elegant of a solution as Caleb has described for us today. Having said that, if you guys have made it this far on podcast or YouTube or any other forums, please do the like and share and subscribe and follow and all of those other things. Until next week, we'll see everyone soon. Thank you. Bye-bye.